As tradition, on December we talk about DOS. Have you ever asked yourself how to connect a modern PC, which obviously runs Linux, with a vintage PC that runs DOS, in order to transfer files between the two PCs? In this video, we'll see how to connect the two PCs using the serial port, and the required hardware and software, and how to overcome all the obstacles, because there are more than one and they are not trivial. For the vintage PC that runs DOS, I'm always using my trusty Olivetti M24, and if we take a look at the back of the PC, we'll notice that there's a 25-pin serial connector. Despite that serial communication technically requires only 3 pins, one transmitter pin that we'll call TX, one receiver pin that we'll call RX, and a ground pin, in the 80s serial ports had 25 pins because they had many other control signals. Given that most of those control signals weren't used by modems, in the 90s the serial port went from 25 to 9 pins, and all the hardware that you find today for the serial port uses 9-pin connectors. So if you, like me, want to communicate with an 80s era PC, you have to find a 25 to 9-pin serial adapter. Please note that despite me showing you products from Amazon, the links are not affiliated. I don't get a single cent from them. I'm showing you these products only because they are the ones that I'm personally using and I know that they work. We were saying, okay, now our Olivetti M24 is compatible with 9-pin serial. Now we need to make compatible with the 9-pin serial also our modern PC. And given that the serial port disappeared from PCs around 2010, you need a USB to serial adapter. I'm showing you this model only as an example, but truly any USB serial adapter that you can find is perfectly fine. Lastly, to connect the two PCs, you need a so-called null-modem cable, that is a crossover cable. Beware! There are various kinds of null-modem cables, the simplest one being made only with 3 pins, where TX and RX are crossed, so the transmitter from one side goes to the receiver on the other side, and vice versa. For us, this cable is not enough. We want a cable that also crosses RTS with CTS and DTR with DSR. This kind of cable is also known as a lap-link cable. When purchasing this cable, I suggest you to take a look at the description if it tells you which pins get connected by the cable. Okay, now we have all the hardware we need. Now, from the software side, to transfer files from one PC to the other, we'll use the z-modem protocol, that is a file transfer protocol that was very popular in the BBS era in the 90s. So we need, both from the Linux side and from the DOS side, a serial communication software that supports the z-modem protocol. On the Linux side we'll need lrzsz, that is the serial transfer program using the z-modem protocol. Minicom, that is the serial communications program. Not strictly necessary, PkLite is another serial communication program that we can use instead of Minicom. What's the difference between Minicom and PkLite? Personally, I find Minicom more featureful and easier to use. However, PkLite allows to manually drive the RTS and DTR pins, which may be useful for debugging certain serial problems. When in doubt, install both, as they are very lightweight. You'll find lrzsz, Minicom and PkLite conveniently packaged for your Linux distribution, so I'm not showing you how to install them. On the DOS side, we have a bit of options. If there's only one DOS program that I suggest using, it's TXZM, also known as Texas Z-modem. It is lightweight, fast, and it also includes a terminal emulator. The only quote-unquote downside that it's free only for non-commercial use, and I like to see who uses the Texas Z-modem on DOS for commercial use nowadays. Another really valid option is PD Z-modem, also known as public domain Z-modem. A little bit heavier than Texas Z-modem, it doesn't have a terminal emulator, but it's public domain in case somebody should care. Optional, there's also BananaCom, that is mainly a terminal emulator, but it also supports file transfers with the z-modem protocol, and it allows you to monitor in real time the status of the CTS and DSR pins, which may be useful for debugging certain serial problems. While we are on the stack.sk website, it has nothing to do with serial communication, but let's download also PkLite version 2.01 that allows us to compress DOS executable files. Very well, now that we have all the software that we need, we have a problem. How do I transfer Texas Z-modem or public domain Z-modem to the DOS PC? Surfing online, I found this website that shows that it's possible to transfer small text files on DOS and gives a utility to convert binary files to their hexadecimal representation and a QBasic program to reconstruct the binary file. This is very interesting, but there's a problem. My Olivetti M24 has DOS version 3.3, and QBasic is found on DOS starting from version 5. However, on DOS versions prior than 5, there's GWBasic, so I took this QBasic program and rewrote it in GWBasic. So, on the Linux PC, download the contents of my fmhex repository from GitHub. Given that QBasic is compatible with files written for GWBasic, my program works on any DOS version. But wait, there's more. To ensure that it's truly compatible with all DOS versions, I know that FreeDOS includes the Bywater Basic interpreter. So I wanted to try my program on Bywater Basic, and I found a bug in the Bywater Basic interpreter. I reported the bug to the FreeDOS project, attaching a patch that fixes the bug. And now I'm proud to tell you that my program written for GWBasic now also works on Bywater Basic starting from version 3.30 on FreeDOS. But enough talking. How do I transfer Texas Z-modem or public domain Z-modem to the DOS PC? As an example, we'll use public domain Z-modem, but it's the same for Texas Z-modem if you want. First of all, let's extract the zip file, and we can see that we have a file called zm.txe. Now we use DOSBox, because I wanted to use PkLite to compress the zm.txe file. If we look at the options of PkLite, we can see that there's the -c option that allows us to put a checksum on the executable. And we need this because this way it is guaranteed that if the file runs, it means that it has been transferred without errors. So we write PkLite -c zm.txe. And this way, our zm.txe file is of way fewer kilobytes, and it has a checksum that prevents it from running if the file contains any errors. Now, let's go back to Linux and copy the zm.txe file in the directory where we downloaded my fmhex project. Now, I didn't say that I rewrote the program that converts binary files to their hex representation in Python, so that it can be easily executed on Linux. Let's write then to hex.py zm.txe and write. I also need to specify the output file name. Let's call it zm.hex. Now, however, the zm.hex file is 92 kilobytes, and if I tried to transfer it on DOS as is, after about 64K, it would error out. So we need to cut this file into two files of less than 64 kilobytes. To do so, I wrote the splithex.py utility, and in this case I'm splitting the file every 1350 lines. This way, I have the zm1.hex and zm2.hex files, each of about 47K. Now we are ready to transfer the hex files and my basic program. As the Linux PC, I'm using a laptop with Debian 12, but any distribution is fine. After connecting the USB serial adapter to the PC, we can see that the devtty USB 0 file is readable and writable only by root and by the members of the dial-out group. So I need to ensure that the current user is a member of the dial-out group, or else I cannot use the serial port. If the current user is not a member of the dial-out group, you can simply type sudo usermod -ag dialout followed by the username, in this case free, and restart the computer, or simply log out and back in. Note that the dialout group is a Debian convention. If you're using a different distribution, the name of the group might be different. For example, on Arch, the name of the group is UUCP, but the procedure is the same. We were saying, on the Linux PC, let's start minicom with the command minicom -b 9600 to set 9600 bits per second, -d devtty USB 0 to use the serial port of the USB serial adapter. Now on the Linux side we are connected and ready to transmit. Let's move on to the DOS PC, and first of all we need to set the serial port to go at 9600 bits per second. So we type the command modcom1 9600 N81P. Now I move into a temporary directory, and to receive the file, let's give the command copy com1 fmhex.bus. Now the PC is listening for writing on the fmhex.bus file everything that it receives from the com1 serial port. Let's go back to our Linux PC and press Ctrl A followed by S to tell minicom to send the file. Select ASCII, then select the fmhex.bus file with the space key and press Enter to start the file transfer. After the transfer has been completed, press Enter to close the window. However, if we take a look at the DOS PC, we see that it's still listening to receive data. Let's get back to our Linux PC and press Ctrl Z to send the hex 1A character that tells the DOS PC that the file is complete. I'm giving the command type fmhex.bus to be sure that the file has been transferred correctly. I don't know why, but the first file that you transfer sometimes has an error on the first character. That is, it could have one extra character at the beginning of the file, it could be missing the first character, or it could have the first character wrong. As you can see, in this case, it lost the first character, but given that having 10 as the first line number instead of 110 is still valid, in this case it's still okay. Let's give the copy command as before to receive the zm1.hex file. Let's get back to the Linux PC and press Ctrl A followed by S to transfer the zm1.hex file. At this point you already know the procedure, so I'm skipping to the part of the video where we transferred both the zm1.hex and zm.2hex files. Now we need to put back together the zm.hex file with the command copy zm1.hex plus zm2.hex zm.hex. And lastly, we use QBasic with my program to reconstruct the zm.exe file. Now, it looks like the PC has frozen, but be patient. We're talking about an 8 MHz PC that is running a basic program, which is notoriously very slow. So to reconstruct the zm.exe file, it takes more than 10 minutes. Let's skip to the part of the video where it finished to reconstruct the file, and we see the OK prompt that tells us that we're still running in QBasic. To get back to DOS, just write system. Now, if we try to type ZM, you can see that public domain z-modem is running correctly. Too complicated? I think so as well. The point is that while I was researching for this video, I found out that the Kermit project has created a file format called BOO that is conceptually very similar to the modern Base64, that is, every 3 bytes of a binary file get converted to 4 bytes of text characters. And among the programs for decoding BOO files, I found msbpgg.com, which is a DOS program for decoding BOO files, but for some strange black magic, it is made only of printable text characters. And while I was at it, I rewrote the program for encoding BOO files in Python so that it can easily be executed on Linux. So, everything that we have seen so far has been completely useless. Or rather, it works, but there's a way easier method to transfer public domain z-modem or TXZM to the DOS PC. Let's see it. we still have our zmodem.exe file compressed with PkLite, and type the command toBoo.py zmodem.exe zmodem.boo. Given that the boo file is under 64K, I don't need to split it. I can already start minicom. On the DOS PC, we use the usual modem copy commands for receiving via serial. From the Linux PC, the usual Ctrl-A followed by S to send the file. So from the DOS PC, we can see that it lost the first character of zm.boo. With a text editor, I'm fixing the first character. And now I can run the command msbpcg.com zm.boo. And in very few seconds, it reconstructs the zm.exe file. Now that we have a z-modem file transfer program on the DOS PC, we can transfer binary files of any size with baud rates higher than 9600 bits per second in a reliable way, because the z-modem protocol implements error correction based on CRC. To receive files with public domain z-modem, we use the command zdem -c1 to use the COM1 port, -b 38400 to go at 38400 bits per second, -d to ignore the DCD signal, -h to ignore the CTS signal, rz to receive files, and c:temp to put the received files in the c:temp directory. On the Linux PC, we use the usual minicom command, but we are going at 38400 bits seconds instead of 9600. Side note, the PC serial port, in theory, goes up to 115-200 bits per second, but an Olivetti M24 is too slow to handle the speed. I found out that on Olivetti M24, the maximum speed is 38400 bits per second, and already at that speed there are a few errors. Now, as usual, let's press Ctrl-A followed by S to transmit a file, but this time let's select the z-modem protocol. Let's transfer, for example, the Texas z-modem archive file. Speaking of which, let's see how to receive files with Texas z-modem. TXZM COM1 -b 38400 -e to ignore the DCD signal, -r to receive files, c:temp as before to put receive file in c:temp. In order to not write a very long command line each time, if you want, you can create a .bat file that calls public domain z-modem or Texas z-modem with these options and execute the .bat file for convenience. I'm not showing you how to do it because it's outside the scope of this video. On the Linux side, exactly like before, Ctrl-A followed by S, z-modem protocol, and this time, for example, we transfer the CGI version of the Commander Keen Episode 4 video game. As you can see, both public domain z-modem and Texas z-modem work perfectly well. Feel free to choose which one you like the most. Personally, I prefer Texas z-modem because it's lighter than public domain z-modem and it also includes a terminal emulator. Speaking of terminal, as a bonus, I'd like to show you two things that are completely useless, but it's really cool that it can be done. If I run the command TXZM -b 9600 -i-u, here's a terminal emulator that goes at 9600 bits per second. On the Linux side, I can run the command sudo systemctl start serial get tty at tty-usb0 to enable the login from the serial port tty-usb0. Now, from the DOS PC, I can log in and use my DOS PC as a terminal for the Linux PC. Just one thing. For some strange reason, the fish shell does not work via serial, so make sure that your user is using bash as the login shell. I can run any command line program and you see that it works perfectly. However, if I try to run a TUI program, for example my Frank Commander, you see that the terminal goes crazy. I suppose on one hand because of not recognized escape sequences, and on the other hand because of UTF-8 characters that obviously are not recognized by DOS. Too bad, but already the fact that I can give all the commands from the DOS PC is cool. But wait, there's more. I can also do the opposite, that is, using my Linux PC as a terminal for the DOS PC. From Linux, it's enough to run minicom with 9600 bits per second. From the DOS PC, I set the serial port to 9600 bits per second with the mod command. Next, I need to make sure that any program that enables the command history and tab file completion, like wced, toddy, or in my case dosed, are disabled because they interfere with the ctty command. So, for example, for dosed, I have to type the command dosed-off to temporarily disable it. Now I can give the command ctty-com1, and here's the DOS prompt on my Linux PC. Also here, I can run command line programs without any issue. But if I try to run a TUI program, like for example Volkov Commander, it doesn't work as expected, because it doesn't get shown via serial, but directly on the monitor of the DOS PC. To go back using the DOS PC, you can give the command ctty-con. Thanks for watching. You can find this video both on YouTube and on Odysee. You can find all the links in the description. Please like and comment this video. I would tell you to subscribe to my channel, but almost all my videos are in Italian. Nevertheless, if you understand Italian and you like Linux, programming and retro computing, subscribe to my channel as well. See you on the next video. Ciao! But we are going at 3800 for... yeah. Side note. The PC serial port, in theory, goes up to... ciao.